Okay, this video is notes on that worksheet that is equations from graphs. We've done this before when we were doing the applications worksheet and stuff for sine and cosine. Now this is for the other four, so secant, cosecant, tangent, cotangent. Now first, when you look at the graph, we should be able to recognize which one it is. Like this one, as soon as you see all those up and down parabolas, we should know that this one's either secant or cosecant. So the first thing when you look at this, say, okay, yeah, I see up and down parabolas. So that's either cosecant or secant because of the up and down parabolas. And it really doesn't matter which one you do. Either one will work, depends on what you see the best. So the first thing, we've done this before, we have some formulas for vertical shift. We know vertical shift is max plus min divided by 2. Well, here the max is where there's an up parabola. Well, that's up at 4. The min is where a down parabola, that's at 0. So 4 plus 0 divided by 2, our vertical shift is 2. Our amplitude is max minus min divided by 2. So 4 minus 0 divided by 2, so our amplitude is also 2. Now to kind of help you with the period and stuff, I think it's helpful to draw your axis in. Wherever your vertical shift is, that's where your axis is. So here, my vertical shift is 2, so I go up here at 2, I'm going to draw my axis in there. So there's my axis right through the middle of there, if you can see that. There's my axis. Now, let's sketch in a sine or cosine curve. So this is an axis point. It's going to go down. There's going to be a trough through an axis point, crest, axis point, trough, axis point, crest, axis point, and so on. I think that helps you see what's going on there if you sketch that in there. All right. So now for the period, well, we know period is crest to crest or trough to trough. Well, here, if we go crest to crest, like here's a crest, here's a crest. Well, they are 1, 2, 3, 4, 5, 6, 7. That's 8 spaces. So 8 spaces is 8/6 pi, which is 4/3 pi. So we can count that, or you can count trough to trough. 1, 2, 3, 4, 5, 6, 7, 8. 8 spaces. Remember, each space is pi over 6, so that's where we get the 8/6 pi from. So that's 4/3 pi. Now remember, the period doesn't go into our equation. We have to turn that into angular velocity. Remember, angular velocity is the normal period, which for secant and cosecant is 2 pi, just like sine and cosine, divided by the new period. So we have that. Now remember, fractions like that, we take the top times the reciprocal of the bottom. So that simplifies. Let's see, we can cancel a little there. The pi's cancel. That looks like 3/2. So that's our angular velocity. Okay, so those three things, just like we've done before. Now the last thing we need is the horizontal shift. Now this is the only time it depends on whether you're going to do secant or cosecant. Remember, cosecant comes from sine, so it starts with an axis point. So if you look at our curve that we did here, here would be the start of a sine curve right there. Well, that's left pi over 2, so we could use a negative pi over 2 for our horizontal shift. Or a sine curve could start right here. That looks like that's right 5/6, so we could use a positive 5/6 pi. Either one of those would be fine. So if we were doing this equation using, that'd be for cosecant, since we looked at sine, we'd say y equals our amplitude, which is 2. That's cosecant. Our angular velocity, which is 3/2, in parentheses x. If we use negative pi over 2, that'd be plus pi over 2, and then plus our vertical shift. So there would be our equation. If we did it with secant, which I think a lot of times is easier. Remember, secant comes from cosine. Cosine starts with an amplitude. So you look on here, where's there an amplitude? Well, there's one right here because there's a crest. That's left pi over 6. So there, that would be a negative pi over 6. Or there's a crest right here. That's 7 spaces, so that's 7 pi over 6. So if we were using secant, we could use that. So our equation would be y equals our amplitude, which is still 2, times the secant, because we're comparing it to cosine, times our angular velocity, which is still 3/2. Now x minus a negative pi over 6, plus our vertical shift, which is still 2. So I think the key is, one, using these formulas, and then comparing them to sine or cosine. I think that makes it much easier. So if we use cosine, we start with a crest for our horizontal shift. I think that's the easiest, is to start with a crest. You could use a trough if you wanted to and just make your secant negative. All right? So that's what you do on secant and cosecant. Again, look and notice it's parabolas. So that's secant or cosecant. Find your vertical shift and your amplitude. Draw your x-axis in there right at your vertical shift mark. Sketch in a sine or cosine curve. Then you can see the period, crest to crest or trough to trough. Find how that becomes the angular velocity. Then you decide secant or cosecant. Again, I think secant a lot of times is the easiest because it starts with a crest. So you can say, oh, there's a crest at negative pi over 6. So that's our horizontal shift, negative pi over 6. There's our equation. All right? That's what you do for cosecant and secant. Now, if you have one that's tangent, like if you look at this curve, well, that's obviously a tangent curve or cotangent. We can actually use either one. So as soon as you see it looks like that, we know that's tangent or cotangent. Now, first thing I would do is on this, I would draw an axis right through my center point, right through the axis point. So you can see here's our center point here. I would draw an axis there. That's going to help us find our vertical shift. So for your vertical shift, well, here's the x-axis. Looks to me like our axis is down 1. So if you draw that axis right through that axis there, center point, that's down 1 from the normal axis. So our vertical shift is negative 1. The amplitude on tangent and cotangent, unless it's obvious, you just let it be 1, or if you flip it over, negative 1. So unless it's obvious where that point is at, just make the amplitude on these 1 or negative 1. Now for the period, we have two choices. You can either go asymptote to asymptote, because that's one period, or you could go axis point to axis point, whichever way looks easiest to you. Like here, if you went axis point to axis point, that's 1, 2, 3, 4, 5, 6, 7. That's 8 spaces. So our period is 8 pi over 6, which is 4 pi over 3. Or if you went asymptote to asymptote, that's 1, 2, 3, 4, 5, 6, 7. That's 8 spaces, so 8 pi over 6. Now remember, we want to turn that into angular velocity. So our angular velocity. Now remember that the normal period for tangent cotangent is 1 pi instead of 2 pi. So we're going to take 1 pi divided by 4/3 pi. Easy to forget that. Remember, tangent cotangent, the normal period is 1 pi instead of 2 pi. So if we take the top times the reciprocal of the bottom, the pi's cancel out, and we get 3/4 for our angular velocity. Okay. Now, the only thing left is our horizontal shift. Now this one, because it's going downhill, my first choice would be cotangent. When I see downhill, I think cotangent. So remember, cotangent starts with an asymptote. So for a horizontal shift, if we start with an asymptote, well, there's one right here, just just left of the y-axis. Looks like there is one. So that's left 1 space, so it could be a negative pi over 6. If you use this one over here, or like let's say you use this one here, that's 7/6. You could use or a positive 7/6 pi. So if I was doing this with cotangent, I'd say y equals our amplitude, which is 1, times the cotangent of our angular velocity, which is 3/4, times x. You could use x minus a negative pi over 6, or you could use x minus 7 pi over 6. Either one would work fine. And then plus our vertical shift, which is down 1 for minus 1 for a vertical shift. Now you could also use tangent on this one. even though it's going downhill, you could use tangent. Because remember, to make it tangent is just a cotangent flipped over, so you could make your amplitude a -1 instead and make this tangent. Now remember, tangent starts with an axis point. So here we have an axis point. Looks like there's one right here at pi/2, or there's one over here at, looks like -5 pi/6. So we could use either one of those. So now our equation would be y equals, if we're going to use a negative amplitude, so when it goes downhill, if you want to use tangent, make the amplitude negative. Then we put tangent. Our angular velocity is still 3/4. And then we can use x minus pi/2, or we could use x minus a -5 pi/6. And then our vertical shift is still down 1. So when it's shaped like this, normally if it's downhill, cotangent's pretty easy. If it's uphill, tangent's pretty easy. You can use either one you want. The only easier thing about using cotangent, it's usually easier to see where there's an asymptote. And that's your horizontal shift for cotangent, where there's an asymptote. All right, and that's it.